December 19th, 2025, 6 days before Christmas, just 40 days from now. Mark that date. Because on that day, 3C Atlas will make its closest approach to Earth. There's no danger. It will pass at a distance of about 267 million kilometers, roughly 1.8 astronomical units. Far too distant for any threat of collision, but close enough that every major telescope on the planet will be watching. Close enough to reveal details we've never seen before. Close enough that if this object is anything other than a natural comet, we'll know. And that's why December 19th matters more than any other date in this story. It's the final opportunity. After this approach, Atlas drifts back into the darkness, moving away from both Earth and the Sun, fading below the reach of even our most powerful telescopes. By March 2026, it will be too faint to detect. By summer, it will vanish completely, swallowed by the immensity of interstellar space, gone forever. If we're ever going to uncover what this object truly is, comet or craft, natural or designed, the clock starts now. 40 days to find the truth before the window closes forever. NASA knows this. That's why the Hubble Space Telescope, the James Webb Space Telescope, and radio observatories across the globe have all reserved precious observation time for mid-December. That's why the Planetary Defense Protocol, first activated on November 2nd, remains in full effect through the coming approach. And that's why astronomers everywhere are calling the next 6 weeks the most critical observation campaign in the history of interstellar research. 40 days from now, 6 days before Christmas 2025, humanity may receive one of two gifts: either the greatest confirmation imaginable that we are not alone, or the most unsettling revelation of all, that something from beyond our solar system has been watching us, studying us, approaching us deliberately. The countdown began 11 days ago, when Atlas passed perihelion on October 29th, its closest point to the Sun. In that moment, it reached extreme temperatures and began behaving in ways that no natural comet ever should. It brightened 16 times faster than models predicted. It turned bluer than the Sun itself, radiating light with thermal signatures that hinted at internal heat sources, hotter even than the solar photosphere. And then it accelerated, altering its path in ways that can't be explained by simple outgassing or solar pressure. Those perihelion anomalies forced NASA to act, triggering the November 2nd protocol activation. Now, with just 40 days left until its closest pass, every fragment of data collected since July is being re-examined with fresh urgency and growing unease. Because December 19th isn't just another observation window, it's the culmination, the moment when Atlas draws close enough to Earth for our finest instruments to reveal what distance is hidden. At 267 million kilometers, Hubble's resolution can discern structures only a few hundred kilometers wide. If Atlas has surface geometry, symmetry, or patterns that look anything but natural, Hubble will see them. Meanwhile, the James Webb Space Telescope will be listening in its own way, through light. Its infrared spectrometers can detect molecular traces at concentrations far below what earlier observations could reach. If this object is releasing industrial compounds, propellants, or anything that doesn't belong in a comet born of ice and dust, Webb will find it. And then there are the radio telescopes, humanity's ears in the dark. From the Very Large Array in New Mexico to the Parkes Observatory in Australia, a synchronized watch will begin on December 18th, continuing through the 20th, covering both hemispheres of the sky. If Atlas is transmitting, whether intentionally or as leakage from some internal system, they'll hear it. The monitoring will focus on the hydrogen line at 1.42 GHz, the universal frequency SETI researchers believe most likely for deliberate communication, and on additional bands used for spacecraft telemetry and radar operations. 40 days from now, we might not just see Atlas, we might hear it. The timing is symbolic. December the 19th falls just 6 days before Christmas, a week when much of the world turns inward, toward family, faith, and celebration. If the observations reveal something extraordinary, if that day becomes the moment we confirm Atlas is not just a comet but something technological, The announcement will arrive at a time when billions of people are already asking the oldest questions. Who are we? Why are we here? Are we alone? The juxtaposition feels almost poetic. Christmas, a holiday built around stories of celestial visitors bringing messages of hope and transformation. Might this time be preceded by the arrival of a real visitor from the stars themselves? But the timing also brings challenges. If anomalies appear on December 19th, immediate follow-up observations will be vital to confirm, to verify, to understand. And yet, during the holidays, observatories close, staff go home, and decision-making slows. NASA has already planned for that. The agency has declared December 15th through the 25th a continuous operations window. Key personnel have been asked to remain on duty. Major observatories have committed to extended schedules, and communication lines between institutions will stay open straight through the holidays. The message is unmistakable. Whatever happens on December 19th, the world will be ready to respond, immediately and together. The approach distance, 267 million kilometers, was calculated months ago, refined through thousands of observations since Atlas was first discovered in July, but trajectories can change. The non-gravitational acceleration detected at perihelion proved that Atlas's motion isn't governed by gravity alone. Something, perhaps outgassing, perhaps propulsion, is altering its velocity. If another acceleration occurs between now and December 19th, the approach distance could shift. It might move farther away, perhaps beyond 300 million kilometers, reducing the clarity of our observations. Or it might move closer, within 200 million kilometers, sharpening our instrument's view, but raising new questions about intentionality. Inside NASA, a dedicated task force has been running simulations around the clock, exploring these what-if scenarios. If Atlas accelerates toward Earth, cutting the distance dramatically, does that suggest deliberate targeting, or is it coincidence, a natural adjustment that merely appears purposeful? According to reports, the task force has built decision trees, protocols for interpreting acceleration events based on magnitude, direction, and timing. These frameworks remain classified, not shared with the public. But their very existence reveals something extraordinary. NASA is preparing for possibilities that just a year ago would have been dismissed as pure science fiction. There's also the question of what we really mean by close enough. At 267 million kilometers, Atlas will become the closest confirmed interstellar object ever observed in detail. Back in 2017, Oumuamua passed within just 24 million kilometers, but it was discovered after its closest approach, leaving scientists with little more than fragments of data. 2 years later, Borisov crossed our solar system at 300 million kilometers, slightly farther than Atlas's predicted path. For an interstellar visitor, 267 million kilometers is remarkably close enough to capture information that was impossible before. But close is always relative. Mars at its nearest comes within 55 million kilometers, Venus within 38 million. If Atlas were that near, we could see its surface directly with Earth-based telescopes, detect its radio signature with modest antennas, even use radar to map its structure in 3 dimensions. At 267 million kilometers, we're limited. Only space telescopes and the world's largest radio dishes can reach it. We can see, but not with the clarity we crave. We can listen, but only for signals strong enough to cross the abyss. The December 19th observations will be the best humanity can achieve, but they won't be perfect. There will be ambiguities, uncertainties, and endless debate about what we truly saw and what we might have missed. This ambiguity is both frustrating and necessary. If the data on December 19th were perfectly clear, leaving no room for doubt, the consequences would be staggering. If Atlas revealed itself unambiguously as a technological object, the implications would reach far beyond science. Governments would face immediate pressure to respond, to communicate, to prepare, to act in ways no one has truly planned for. but ambiguity buys time. If the evidence remains uncertain, if December 19th brings clues but not conclusions, then the discussion continues. Scientists can debate, governments can wait, and humanity can slowly absorb the possibility without the shock of sudden confirmation. Astrophysicist Avi Loeb has written about this in his recent essays. He calls December 19th humanity's exam, a test of whether we're ready to face evidence that challenges our most fundamental assumption, that we are unique in the universe. Loeb suggests the observations will likely be clear enough to convince open-minded scientists, but ambiguous enough for skeptics to remain unconvinced. And that, he argues, has been the pattern since Atlas was first spotted. Every anomaly, the green glow, the precise trajectory, the unexpected brightness at perihelion adds to the case without ever closing it. Each one whispers possibility, but never shouts proof. December 19th will likely continue that pattern, adding new data points, deepening the mystery without forcing a final answer. But there's another possibility. Maybe December 19th is the day when ambiguity ends. Maybe the data will be so clear, so undeniable, that no reasonable doubt can survive. Imagine it. Geometric structures visible in Hubble's images, industrial compounds traced in Webb's infrared spectra, radio transmissions captured by the Very Large Array. If those signals align, the mystery dissolves, and the question that has haunted humanity for centuries, are we alone, will finally have an answer. If that happens, then these next 40 days are more than just a countdown. They are the final days of the old paradigm, the last brief moment in history when we could still believe, even faintly, that Earth was unique. After December 19th, everything changes. What will we actually see on December 19th? That depends on what Atlas truly is, and whether it's willing to reveal itself. The observation campaign planned for mid-December is the most comprehensive ever attempted for an interstellar visitor. It brings together space telescopes, ground-based observatories, and radio arrays spread across 6 continents. Each will search for different clues, different signatures, that might confirm or refute the idea that Atlas is more than a natural comet. And if those instruments all detect anomalies, if the data from light, heat and radio converge on the same conclusion, then December 19th becomes the day the question is finally answered. The Hubble Space Telescope will begin its watch early on December 15th and 16th, just days before closest approach. Using its full spectral range from ultraviolet at 200 nanometers to near-infrared at 1000. Hubble will capture high-resolution images of the object and its coma, the cloud of gas and dust surrounding its nucleus. In natural comets, that coma is chaotic, a shapeless blur sculpted by random bursts of gas and the solar wind. But if Atlas's coma shows order, jets aligned in geometric patterns, or edges too precise for turbulence to create, that would be something else entirely. That would be evidence of control. At a distance of 267 million kilometers, Hubble's resolution is about 500 kilometers per pixel. That means any structure larger than a few hundred kilometers could be visible if it stands out clearly against the glowing dust and gas of the coma. A spacecraft the size of a city would appear as a brilliant point buried within that haze, and if there are surface features, antennas, solar arrays, or engine nozzles large enough and facing the right way, they could manifest as subtle asymmetries in the brightness pattern. The images won't reveal fine detail, but they'll tell us what matters most. Is Atlas symmetric or irregular? Smooth or structured? Point-like or extended beyond what a natural nucleus should be? The ultraviolet images will be especially critical. Natural comets glow brightly in the UV as sunlight splits apart water and carbon dioxide, producing hydroxyl radicals and carbon monoxide that fluoresce at specific wavelengths. If Atlas's UV spectrum matches that familiar pattern, it strengthens the natural hypothesis. But if the spectrum reveals unexpected emissions, light at wavelengths where no known comet chemistry shines, then something else is at work. Something generating energy in ways nature doesn't. Industrial reactions, combustion, plasma discharges. Each leaves behind a distinct ultraviolet fingerprint. If Atlas carries such a signature, it won't just reflect sunlight. It will announce itself. On December 17th, the James Webb Space Telescope will take its turn. Using its near-infrared spectrograph, Webb will measure Atlas's molecular composition with a level of sensitivity no instrument has ever achieved. Webb operates in the infrared wavelengths longer than visible light, where warm objects emit thermal radiation, and where molecules reveal themselves through unique absorption and emission lines. For comets, infrared spectroscopy is a chemical fingerprint. It tells us what they're made of, distinguishing water from carbon dioxide, methane from ammonia, and identifying whether the materials are simple ices or complex organics. But Webb's power goes far beyond natural chemistry. It can also detect molecules that have no place in a comet. Hydrazine, a common spacecraft propellant, leaves deep absorption bands in the infrared. So does nitrogen tetroxide, another chemical fuel. If Atlas vented propulsion gases during its perihelion maneuver, traces of those compounds could still linger within its coma 40 days later, and Webb is sensitive enough to find them, even at concentrations far below what visible light instruments could ever detect. A positive detection of such propellants wouldn't just be unusual, it would be a smoking gun, the unmistakable signature of technology. Webb will also measure thermal emission, the faint infrared glow radiating from Atlas's surface. For a natural comet at 1.8 astronomical units from the Sun, surface temperatures hover between 200 and 250 Kelvin, bitterly cold, with thermal light barely detectable and dominated mostly by reflected sunlight. But if Webb detects heat stronger than those models predict, it would mean one thing: Atlas is warmer than sunlight alone can explain. That warmth could come from internal heat sources, power systems, engines, or mechanisms generating waste energy deep within the object itself. Any of these would elevate surface temperatures and produce a measurable infrared excess. During its perihelion passage, Atlas appeared bluer than the Sun, implying emission temperatures above 5800 Kelvin. If that blue glow was genuine, if it came not from the surrounding coma but from the nucleus itself, then Webb should see clear infrared signatures of extreme heat. While Webb and Hubble alternate their view from space, the ground-based campaign will operate without pause, from December 14th through December 21st. These observatories will fill the gaps, capturing variations that single snapshots might miss. In Chile, the Very Large Telescope will use its SPHERE instrument, a state-of-the-art adaptive optics system that cancels atmospheric distortion, pushing ground-based vision to near-space quality. SPHERE also carries a coronagraph, a specialized mask that blocks the brilliant glare of the coma, allowing astronomers to isolate the faint nucleus beneath. If it succeeds, this will mark a first in human history, a direct image of Atlas's nucleus, revealing its size, shape, and reflectivity. Shape tells a story. In nature, comet nuclei are irregular, potato-shaped, fractured, sculpted by billions of years of collisions and uneven outgassing. But if Atlas's nucleus is symmetrical, spherical or cylindrical, that would be something else entirely. That would be evidence of design. Perfect spheres are rare in nature. They require uniform materials and a formation process untouched by external forces. Cylinders are even rarer, demanding precise rotation around a single axis and the deliberate smoothing of irregularities. If spheres' images reveal a geometric nucleus, space agencies will have hours, not days, to decide how to respond. Meanwhile, spectroscopic observations from ground-based telescopes will complement Webb's data, covering wavelengths Webb can't reach and tracking changes over time, minute by minute, hour by hour. At the Keck Observatory in Hawaii, astronomers will conduct nightly observations from December 15th through the 20th, using a high-resolution spectrograph to search for emission lines from unusual molecules. Of special interest are metallic lines, those bright razor-sharp wavelengths produced when metals vaporize under extreme heat. Earlier observations detected a faint nickel emission, already unusual for a comet. If that nickel line remains visible on December 19th, and if it's joined by iron, titanium, or other metals, it would point to temperatures and processes no natural comet could sustain. Evidence, not of geology, but of engineering. Radio observations will begin on December 18th, one day before closest approach. In New Mexico, the Very Large Array will turn its antennas toward Atlas, observing continuously for 12 hours, swooping through frequencies between 1 and 10 GHz. Within that range lies the hydrogen line, at 1.42 GHz, a frequency often called the universal channel for interstellar communication. Hydrogen, the most abundant element in the cosmos, emits there naturally, and the surrounding spectrum is remarkably quiet, free from interference. If Atlas were to transmit deliberately, 1.42 GHz is where the signal would likely appear. But the VLA will be listening more broadly. Spacecraft telemetry often uses S-band, around 2 GHz, and X-band, near 8 GHz, the same bands used by radar and deep space communication systems. If Atlas possesses active technology, communication links, navigation systems, or radar mapping instruments, those transmissions would emerge somewhere within that 110 GHz window, and the VLA is sensitive enough to detect them. At this distance, even a transmitter no stronger than a cell phone would register as a faint whisper from the dark. Anything more powerful, anything built for long-range communication, would stand out unmistakably. In the southern hemisphere, the watch will pass to Parkes Observatory in Australia. On December 19th and 20th, Parkes will observe while the Very Large Array lies in darkness, providing full coverage as Earth turns beneath the stars. Parkes is among the most sensitive single-dish radio telescopes on the planet, and it carries a legacy. In 1977, it helped track the Voyager probes on their journey beyond the solar system. In the 1990s, it detected the first mysterious fast radio bursts, signals that seem to echo from the depths of distant galaxies. If Atlas transmits on December 19th, and if the signal is strong enough to cross 267 million kilometers of space, Parkes may be the first to hear it. But detection is only the beginning. If a signal appears, confirmation must follow. Protocol demands that a second telescope, either the VLA if Parkes hears first, or Parkes if the VLA does, must observe the same frequency and confirm the signal is real and that it is coming from Atlas, not from terrestrial interference. That confirmation process takes minutes to hours. Once verified, the data is sent to NASA and the International Asteroid Alert Network for analysis. Then begins the real question. What kind of signal is it? Is it continuous or pulsed? Broadband or narrowband? Modulated, carrying information, or merely a steady hum of technology? The structure of that signal will reveal its nature, whether it's a natural phenomenon, a technological byproduct, or something deliberately communicative. Natural radio emission from comets is almost never strong. Comets don't broadcast, unless they pass through a planet's magnetic field, which Atlas won't at 1.8 AU. They're radio quiet. So if a strong radio signal is detected from Atlas, the conclusion will be almost unavoidable. It's technological. And if that signal is modulated, if its structure changes over time in a way that clearly carries information, then the question shifts instantly from, is this artificial, to what is it saying? Humanity has actually planned for this. The SETI community and the International Academy of Astronautics have established protocols for exactly this scenario, guidelines written over decades by scientists, diplomats, and ethicists. Those protocols say, verify the detection thoroughly, don't respond immediately, inform governments and international bodies, and decide together whether humanity should speak and what it should say. But there's a problem. Those guidelines were written for a signal coming from light years away. From a distant, untouchable civilization we'd have decades to study and debate. Atlas is different. If the signal is coming from 267 million kilometers away, from an object that is currently approaching Earth, perhaps even capable of maneuvering, then the timeline collapses. Decisions that were meant to take years would have to be made in days, maybe even hours. This is why the December 19th task force isn't made up of astronomers alone. At the table are policy advisors, officials from NASA's Planetary Defense Office, representatives from the US State Department and the Department of Defense. Because the questions being asked now are no longer just scientific, they're diplomatic, they're strategic, they're about who hears what and when. The discussions, according to briefings, are built around branching scenarios. If Hubble images show geometric structure, what's the immediate follow-up? If Webb detects propellant signatures, who is notified first? NASA leadership, the White House, the UN. If radio telescopes receive a signal, do we respond at all? And if we respond, who has the authority to speak for Earth? These are no longer hypothetical exercises. The perihelion anomalies show that Atlas is not behaving like any natural comet we've ever studied. The November 2nd protocol activation showed that NASA is taking the technological explanation seriously enough to prepare, and the coordinated scheduling of Hubble, Webb and World Radio Arrays in mid-December shows something else. The scientific community is getting ready for the possibility that December 19th is the day we stop guessing and start knowing. Astrophysicist Avi Loeb calls December 19th humanity's final exam. He believes that how we face this moment, whether with open minds or rigid skepticism, will define whether we recognize a true shift in understanding when it arrives. History offers its warnings. For centuries, scientists dismissed meteorites as myth, until stones literally fell from the sky. Ball lightning was written off as illusion, until cameras caught it flickering across storms. Loeb suggests Atlas could follow the same path, its evidence clear enough for those willing to see, yet ambiguous enough for doubters to cling to disbelief. But there's another path. Maybe December 19th is the day when denial finally ends. When the data converge, Hubble's images, Webb's spectra, VLA's signals and the weight of evidence collapses the wall of doubt. If that happens, these next 40 days are the last days of uncertainty, the final stretch of time when humanity can still wonder. After December 19th we will know. Either we are alone, awaiting a silent passerby from the stars, or we are not, and the visitor we've watched for months has come bearing an answer. 6 days before Christmas, humanity may receive the oldest gift of all, the answer to the oldest question we've ever asked. What if it doesn't go according to plan? What if Atlas doesn't cooperate with our observation window? What if, sometime in the next 40 days, it changes course again, accelerates unexpectedly, or displays a new kind of anomaly that forces us to rewrite every prediction we've made? The December 19th campaign is built on assumptions that Atlas will continue along a mostly gravitational path, nudged only by the weak, non-gravitational forces we've already detected. But if those assumptions are wrong, if the object is capable of larger intentional maneuvers, then 40 days is a very long time for things to change. That's why the task force assembled on November 2nd has been running contingency simulations non-stop. They're asking, what happens if Atlas accelerates again before December 19th? The models explore a whole spectrum of possibilities. Small velocity changes, just a few meters per second, would shift the closest approach distance by millions of kilometers. That would change the geometry of our observations, maybe make some instruments less effective, but it wouldn't break the campaign. But large maneuvers, accelerations of hundreds of meters per second, are different. Those could move Atlas tens of millions of kilometers closer, or farther, close enough to sharpen our view dramatically and raise questions about intent, or far enough that even Hubble and Webb struggle to see it at all. If Atlas were to move closer, from 267 million kilometers to 200 million or less, the effect would be immediate and dramatic. Every observation would improve. Hubble's resolution would sharpen, able to resolve smaller structures. Webb's infrared spectrographs would pick up fainter molecular traces. Even the radio arrays could detect weaker transmissions with ease. From a scientific standpoint, a closer approach would be a gift. Better data, clearer answers, a more complete picture of what Atlas truly is. But it would also raise an uncomfortable question. What if the approach is deliberate? Not collision, the distance would still be vast, but an intentional adjustment, a controlled positioning that brings Atlas closer to Earth, perhaps to observe us as we observe it. According to leaked task force reports, this possibility has already been discussed behind closed doors. If Atlas's trajectory changes in a way consistent with course correction toward Earth, NASA will have to make a decision, not about science, but about communication. Do they announce the change immediately, risking confusion or panic? Or do they wait, gather more data, and speak once they understand what's happening? The leaks suggest a compromise strategy. Announce the trajectory change factually, describe it as non-threatening but unusual, and emphasize that the December observation window will bring clarity. The goal is simple: transparency without panic. If Atlas moves farther away, the opposite problem arises. Every observation becomes harder. At 300 million kilometers or more, Hubble's resolution falls below the threshold needed to resolve fine structure. Webb's spectroscopy grows noisier, its instruments forced to collect light for longer periods just to separate faint molecular lines from background noise. Even radio telescopes would need a much stronger signal to register anything at all. A distant pass would be scientifically disappointing, data thin and uncertain, the mystery lingering unresolved, but it would also ease the world's unease. An object moving away from Earth feels less deliberate, less like a visitor adjusting its position, and more like coincidence, a curiosity of celestial mechanics rather than intent. Yet there's a third, stranger possibility. The object might not move closer or farther, but sideways. The task force simulations have modelled that too, scenarios where Atlas shifts perpendicular to its current trajectory, altering the constellations it appears against in the night sky. Such a manoeuvre would be almost impossible to explain naturally. Outgassing can push a comet toward or away from the Sun, along the solar object line, never sideways, never at a right angle to sunlight. A lateral course change would mean jets firing in directions unrelated to solar heating, something no natural comet could produce. If that happens, if Atlas slides silently across the stars in a way that defies physics as we know it, then the question of control is no longer speculation, it becomes evidence. The task force has even modelled what they call the stop scenario, the possibility that Atlas decelerates so dramatically it no longer escapes the solar system. Such a manoeuvre would require an enormous delta V, a change in velocity measured not in meters per second but kilometers. No natural comet could do this. Outgassing can nudge a body by a few hundred meters per second over months, but it cannot halt a hyperbolic trajectory within weeks. If Atlas were to slow that much, if it transitioned from an escape path to a bound orbit around the Sun, it would be unambiguous. That would be propulsion. The stop scenario has already gripped the public imagination. Across online forums and discussion boards, people have begun to speculate. What if Atlas isn't just passing through? What if it's a probe designed to reconnoitre the solar system, surveying, studying, and then choosing where to linger? And if it does stop, where would that be? At Earth's distance, it would imply focused interest in our planet, in us. At Mars's distance, it might suggest a broader observation of both Earth and Mars, two neighbouring worlds that may hold biological or technological interest. And if Atlas stops within the asteroid belt, that opens a different interpretation altogether, one of resource acquisition, harvesting ice or metal from ancient rocks drifting between Mars and Jupiter. Each stopping point would tell a different story. Each would hint at intent and purpose. But if Atlas stops, another question emerges, one far more profound than trajectory or distance. What happens next? If the object remains in the inner solar system, no longer departing but lingering, does that mean it intends to communicate? The December 19th radio campaign was designed for a flyby, a brief encounter, a few precious hours of listening before the signal fades into the void. But if Atlas stays, the entire strategy shifts. Suddenly, continuous monitoring becomes possible. We could listen not for minutes, but for hours, days, even weeks, searching for structure in the noise, for patterns that might carry meaning. And if those patterns appear, if we detect a signal that isn't random, one that encodes information, then the question of response becomes unavoidable. That decision, the question of whether humanity should reply, is the most divisive issue within the December 19th task force. The SETI protocols are clear. No single nation should answer alone. No transmission should be sent without international consultation and consensus. Governments, scientists, and global institutions must decide together what to say, if anything at all. But consensus takes time, and time may be the one thing we don't have. If Atlas is waiting, if it's listening for a response, delay could be misunderstood as silence, or worse, rejection. Some within the task force reportedly advocate for a simple gesture, a short non-verbal acknowledgement, a narrow band pulse transmitted on a frequency Atlas might already be monitoring, a way of saying, "We see you, we're listening." Others insist that any reply would be premature, that until we understand Atlas's nature, its capabilities, its intentions, silence is the only prudent choice. For now, that question remains unanswered, hanging in the air between Earth and the visitor that may already be listening. Avi Loeb has already entered the debate. In a post published on November 7th, he argued that if a clear signal is detected, humanity must respond. His proposal is simple, elegant in its logic. Begin with prime numbers, a universal mathematical sequence any technological intelligence would recognize. Then transmit basic facts about Earth, our orbit, the number of continents, our population. Nothing ideological, nothing threatening. Just the quiet introduction of a young civilization saying, "We exist." Loeb's position is that silence is the greater risk, that refusing to answer could be misread not as caution, but as fear or hostility. Curiosity, he writes, is what brought us this far. It should also guide our first conversation with the stars, but critics see it differently. To them, sending a reply without knowing who or what we're answering is reckless. Atlas could be benign, a robotic observer from a peaceful civilization, or it could be something else entirely, a vanguard, a scout sent to measure and report. For them, the lesson of history is clear. Observe first, learn everything you can, and speak only when ready. The argument echoes decades-old debates within SETI, those surrounding active messaging, the idea of broadcasting signals to nearby stars. Even then, scientists were divided between openness and self-preservation, but with Atlas, time has collapsed. This isn't a question for the next century, it's a decision that may need to be made within weeks. And if a signal comes on December 19th, humanity's first answer, or its silence, will speak volumes. Another scenario the task force has planned for is sudden brightness changes. Atlas has already shown it can behave unpredictably. At perihelion it jumped to magnitude 7 or 8, when models said it should have been closer to magnitude 11. That kind of spike means extra energy from somewhere, stronger outgassing, rapid surface heating, or activity from internal systems. So brightness is now being watched like a heartbeat. If Atlas brightens again before December 19th, it could be the first sign that something new is happening, a system activating, a maneuver beginning, or material being vented. By monitoring the light curve continuously, astronomers can get hours to days of warning before those behaviors fully manifest. And here, amateur astronomers become essential. Professional observatories can't watch Atlas every night. Telescope time is booked, weather intervenes, instruments are committed to other targets. But amateurs, with modest backyard telescopes and CCD cameras, can watch every clear night. In fact, several amateur networks have already organised global campaigns, observers in Europe, the US, Australia, South America, handing off the target as Earth rotates, making sure someone is always looking. If Atlas brightens suddenly, it probably won't be Hubble or Webb that sees it first. It'll be a person in a backyard, under a cold December sky, who notices Atlas just got brighter. And that will be the signal for the big telescopes to turn. The November 11th re-emergence, just 2 days away, marks a crucial turning point. It will be the first opportunity for ground-based telescopes to observe Atlas since it passed perihelion. For the past 2 weeks, Atlas has been hidden behind the Sun from Earth's perspective, invisible, unreachable by any telescope on the ground. But on November 11th, it will return to view in the pre-dawn sky. Faint but visible again for the first time since late October, these first observations are critical. Astronomers will measure its brightness, colour and exact position, and compare those readings to the pre-perihelion data. If Atlas now appears brighter or dimmer, bluer or redder, or even slightly off its predicted track, that will mean one thing: something happened while it was hidden behind the Sun. The 2-week blackout was unavoidable but frustrating. While ground-based observatories couldn't see Atlas, solar monitoring satellites could, recording its perihelion brightness spike and that mysterious blue emission that defied all comet models. But those instruments lack the resolution and spectroscopic precision of terrestrial telescopes. That's why November 11th matters so much. It marks the return of high-quality data the moment Earth's best instruments come back online, and whatever those first nights reveal, whether Atlas has changed or not, will set the tone for everything that follows, shaping what astronomers expect to find on December 19th. If Atlas looks normal on November 11th, matching brightness predictions, following its expected trajectory, and showing no strange colours or emissions, then the December 19th campaign becomes a test of the natural hypothesis. In that case, the perihelion anomalies may have been temporary brief distortions caused by peak solar heating, not evidence of anything artificial. Perhaps December 19th will simply reveal Atlas as what it first appeared to be, an unusual but ultimately natural interstellar comet. If that happens, the Planetary Defense Protocol will quietly scale down, the task force will dissolve, and Atlas will slip into the archives of astronomy as a cosmic curiosity, a natural object with a few unexplained quirks, remembered for the excitement it caused before fading into the black. But if November 11th tells a different story, if the object remains brighter than expected, if its spectral lines refuse to match any known comet chemistry, or if its position suggests continued acceleration, then December 19th will no longer be a test. It will be confirmation. Because anomalies that persist are much harder to explain away. Natural comets calm down as they move away from the Sun. Their outgassing fades, their activity drops, their light curve smooths into predictability. If Atlas defies that trend, if it stays active, or becomes more active at distances where every known comet goes quiet, then the technological hypothesis moves from speculation to something far more compelling. There's also the psychological weight of the 40-day countdown. Everyone involved knows that December 19th is the final window, the last chance to truly see Atlas before it disappears into the dark. That knowledge creates a quiet urgency. Every clear night becomes precious. Every spectrum, every image, every data point could be the single piece of evidence that tips the balance from speculation to certainty. Astronomers are working under a pressure usually reserved for supernova alerts or asteroid impact threats, events measured in hours, not weeks. But this isn't a disaster to avert, or a fleeting light to capture before it fades. This is a mystery to solve, and the clock is ticking. For the public, the countdown feels different. Most people don't even know the date. December 19th is just another entry on the calendar, 6 days before Christmas. Media coverage has been sporadic, bursts of attention when something major happens, then silence. The November 2nd protocol activation made headlines for a few days, then was pushed aside by more terrestrial stories. Unless something dramatic occurs before mid-December, public awareness will likely stay low until the results come in. And then, depending on what those results reveal, attention could shift in an instant, from quiet curiosity to global focus, from a footnote in astronomy to the biggest story in human history. NASA is preparing for both outcomes. If December 19th brings ambiguity results that intrigue but don't confirm, patterns that hint but don't prove, the agency will issue a measured statement. It will emphasize continued observation, international collaboration, and the need for patience. It will sound calm, procedural, reassuring scientific language for we're not sure yet. But if the results are definitive, the tone changes. If the data confirm a natural origin, NASA will close the case. Another interstellar comet, extraordinary but explainable. If the data confirm technology structures, propulsion, transmissions, the announcement will not come from scientists alone. It will come from the highest levels, the NASA administrator, or perhaps even the White House, framing the revelation not as discovery, but as history, a moment for humanity to be faced together. But before any statement, there must be observations, and before observations, waiting. 40 days of it. 40 days of contingency planning, of nightly trajectory checks, of rehearsed responses to outcomes no one has truly prepared for. 40 days of watching the skies and wondering if Atlas will behave or surprise us again. Then comes December 19th, the final window. The day when the instruments open, the data flows, and the waiting ends. When we either get our answers, or we don't. Now everything converges. The countdown, the observations, the contingencies. Every calculation, every theory, every sleepless night leads to one inescapable truth. After December 19th, Through Atlas is gone. This isn't poetic language, it's orbital mechanics. Atlas is moving away from both the Sun and Earth at nearly 40 kilometers per second, racing back into interstellar space along a path it will never traverse again. By January 2026, it will fade to magnitude 14, still visible, but only through large research telescopes. By March, it will dim to magnitude 17, reachable only with the world's biggest instruments and long, delicate exposures. By summer, it will sink below magnitude 20, vanishing from even Hubble's reach. The window doesn't just close, it disappears, and that finality is what makes December 19th unlike any other date in the Atlas story. When the green glow appeared on September 7th, there was still time. Weeks of observations ahead, more data to come. When perihelion passed on October 29th, December still felt distant, a milestone we were preparing for, but after December 19th, there's nothing left. No second chances, no do-overs. If the instruments fail, if clouds block the telescopes, if someone points at the wrong frequency for just the wrong hour, the opportunity is gone. Atlas will fade into the cosmic dark, carrying its answers with it, and humanity, all of us, will be left with only our data, our doubts, and our questions. We will spend decades, maybe centuries, arguing over what we saw and what we might have missed. This is why the December observation campaign is built like a machine designed against failure. Every part has a backup, every observation a second chance. Hubble observes on December 15th and again on the 16th, 2 separate sessions, ensuring that even if one is lost to a malfunction or solar interference, the other still captures clean data. The James Webb Space Telescope follows on the 17th, with a backup window reserved on the 18th in case something goes wrong. On the ground, observatories will operate nightly from December 14th through the 21st, overlapping across continents so that clouds, storms, or power failures can't blind the effort. And in radio, the VLA and Parkes Observatory will share the sky between them, covering both hemispheres so Earth's rotation never leaves a gap in the listening. It's planning born from hard experience, a campaign built around Murphy's Law. Anything that can go wrong might. The system is designed so that even if half the instruments fail, enough data will still survive to answer the essential questions. But redundancy can only protect against human and mechanical failure. It can't force Atlas to cooperate. If the object behaves like a perfect comet, if its light curve follows predictions, its spectrum shows ordinary molecules, its coma remains shapeless, and the radio spectrum stays silent, then the campaign will end with no revelation. We'll have pages of data and terabytes of images, and yet the truth will remain elusive. Believers will point back to the earlier anomalies, to the brightness spikes, the strange blue glow, the unexplained accelerations. Skeptics will say it was all noise, artifacts, misreadings, wishful thinking. And December 19th, the day we waited for, will pass quietly, leaving the world exactly as it was before, not with answers, but with uncertainty. This scenario deeply frustrates those who support the technological hypothesis. Astrophysicist Avi Loeb has argued that if Atlas is a probe, it might be designed to hide to appear perfectly natural under scrutiny. In his view, any advanced civilization capable of sending interstellar reconnaissance craft would also understand stealth. A probe meant to observe without interference would likely be equipped with systems to mimic natural behavior outgassing jets that imitate comet activity, light curves that match ice sublimation, even thermal emissions calibrated to solar heating. So, Loeb suggests, when the December 19th observations begin, Atlas could simply shut down. No transmissions, no propulsion, no signatures of power or control. Just a cold, inert nucleus drifting in the dark, an illusion of nature so perfect that even our most sensitive instruments would see nothing unusual. But this idea exposes a paradox that science can't easily resolve. If every null result, every failure to find evidence can be explained as intentional concealment, then the hypothesis becomes unfalsifiable, and science at its core depends on the possibility of being wrong. A valid hypothesis must make testable predictions, statements that could, in principle, be disproven by observation. The stealth probe hypothesis predicts that Atlas will appear natural, but so does the natural comet hypothesis. When two explanations predict the same outcome, they stop being scientific rivals and become philosophical choices, beliefs shaped by curiosity, caution, and the limits of what we can know. And so, if December 19th passes in silence, no anomalies, no transmissions, no clear signs either way. We may find ourselves not with answers but with beliefs. The alternative is that Atlas isn't hiding at all, that it either can't suppress its anomalies or simply chooses not to. If that's the case, then December 19th won't bring mystery. It will bring clarity. Hubble will resolve geometric structure within the coma. Webb will identify industrial compounds molecules no natural comet should produce. Radio telescopes will capture structured signals, patterns unmistakably artificial. The data will be unambiguous. The debate years of speculation, skepticism, and cautious language will end in a single day. This is the scenario both advocates and skeptics are preparing for. The possibility that December 19th becomes not another entry in the observation log, but a turning point in human history. The day the question is finally answered. And yet, another question lingers. Why this date? December 19th isn't arbitrary. It's dictated by the mechanics of orbits, the moment when Earth and Atlas draw closest before the object departs forever. Mathematically, it's coincidence. But symbolically, it's something else. 6 days before Christmas, in the week when billions pause to reflect on origin, meaning, and faith. If Atlas is controlled, if its path was designed, then the timing feels almost intentional. Was it chosen to coincide with the 1 week when humanity is collectively looking upward, when the world's dominant civilization marks stories of visitation, revelation, and hope? It may be coincidence, it may be calculation. Either way, on December 19th, the universe keeps its appointment. This kind of speculation moves into a space most scientists try to avoid. It asks us to assume not only that Atlas is artificial, but that its makers understand us, our calendars, our traditions, even our holidays. That they've been watching Earth long enough to know what Christmas means and timed their approach accordingly. It's a chain of reasoning built from fragile links. Each assumption stretches the bounds of what science can comfortably defend, and yet, it's difficult not to notice the symbolism. If one wanted to approach Earth at a time when billions of people are already thinking about existence, meaning, and the cosmos, then late December would be a perfect choice. A week when humanity turns inward and upward at the same time. There's also a practical side to the timing. The 6 days between December 19th and Christmas offer a buffer, time to analyse, verify and decide before the world's focus shifts to celebration. If something extraordinary is detected, that window allows NASA and its partners to study the data, brief governments, and craft a measured public response rather than rushing to release incomplete findings. Or, more cynically, the same timing could provide cover for delay. Announce preliminary results on December 19th. Promise deeper analysis after the holidays, and let the story dissolve into the noise of year's end, giving officials time to manage the message or perhaps to decide what not to say. Either way, the calendar itself has become part of the mystery. Because if December 19th truly brings revelation, then what follows in those 6 quiet days before Christmas will shape how the world learns it. But delay only works if the findings are uncertain. If December 19th brings clarity, a radio signal with unmistakable structure, a Hubble image revealing a slow cylindrical rotation against the star field, a Webb spectrum showing chemical propellants that could only come from engines, then there's no containing it. You can't hide data like that. Scientists talk, preliminary images circulate, private messages between research teams become public in hours, and once even a hint of such evidence appears, the news will spread through the astronomy community like wildfire, and from there inevitably to the public. NASA can shape the narrative, but it cannot stop it. Truth, once seen, moves faster than protocol. That's why the December 19th task force has spent weeks drafting communication plans for every outcome imaginable. If the results confirm a natural origin, the message is straightforward. A success story of science under pressure, a testament to international collaboration, a celebration of how far humanity has come in understanding the universe around it. But if the results confirm technology, the tone will shift. The statement will acknowledge the discovery's historic magnitude, assure the world that the object poses no threat, outline the next steps, further observation, data sharing, perhaps preparation for contact and call for global dialogue on how humanity should respond. The words will be calm, measured, designed to steady the world at the moment it learns it is not alone. The response question now looms larger than any other. If Atlas is confirmed to be technological, what do we do? Do we speak or stay silent? Leaked reports suggest that even within the December 19th task force, there is no consensus. One camp believes contact is essential. To remain silent, they argue, would be both scientifically negligent and morally wrong. For decades, humanity has poured billions into CT, listening for signs of intelligence beyond Earth. If intelligence has now come to us, refusing to respond would betray the very purpose of that search. To them, engagement is not a risk, it's a responsibility. The other side urges caution. They remind everyone that we know nothing of Atlas's origins or motives. It could be a scientific probe, or it could be something entirely different. A scout, a monitor, a machine whose goals we can't begin to guess. Until we know more, they say, silence is safety. Between these poles, a middle ground has emerged, a plan for passive acknowledgement. If a signal is received, humanity would reply only with mathematics, a short sequence of prime numbers, or a pattern of basic arithmetic, simple, universal, enough to confirm that we've heard and that we recognize the signal as artificial, but revealing nothing of who we are, where we are, or what we're capable of. A digital handshake, not a conversation. It's an approach that balances curiosity with caution, a way of saying, we know you're there, without yet saying who we are. Even the idea of responding opens a deeper dilemma. Who gets to decide what humanity says? Who has the authority to speak for Earth? Is it the United Nations, a coalition of governments, a global council of scientists, or the few individuals who happen to be standing in the control rooms when the signal arrives? History doesn't offer much guidance. In 1974, the Arecibo message was transmitted toward the globular cluster M13, a string of binary digits encoding our solar system, our DNA, our place in the cosmos. It was sent without international approval, a decision made by a handful of researchers at a single observatory in Puerto Rico. But that transmission was symbolic. Its target 25,000 years away. No urgency, no expectation of a reply. Atlas, however, changes everything. If it's truly listening and waiting, the time frame collapses. We would have days, not decades, to decide what to say, and consultation, by its nature, takes time. Time that may not exist. For now, these questions remain hypothetical, because there's still a very real possibility that December 19th will bring no revelation at all. The natural comet hypothesis, while stretched thin by the anomalies so far, isn't dead. There are still mundane explanations to consider. Unusual chemical compositions, exotic dust properties, rare but natural interactions with sunlight and gas. Each anomaly, the brightness spikes, the colour shifts, the trajectory deviations, might be explained individually through coincidence or complexity. The trouble is explaining all of them at once without twisting the limits of probability. So December 19th might come and go without closure. We may end up with more data, more debate, but not more certainty. And the oldest question in human history, are we alone? Will remain suspended in the silence between what we know and what we still can't prove. If that happens, Atlas's legacy won't be the answers it gave, but the questions it left behind. It will be remembered as the third interstellar visitor, the one that challenged our assumptions, that forced us to confront the possibility that we are being observed, and that united the world's observatories in an effort unlike any before. Future interstellar objects will be studied more carefully because of Atlas. The protocols written for December 19th will guide every mission that follows, and the debate, the ancient enduring question of whether we are alone, will continue, but forever shaped by what we learned from this brief encounter. Or, December 19th may be the day that debate ends, the day humanity turns its most powerful instruments toward a traveller from another star and sees, without doubt, that it was built, not born, that we are not alone. 6 days before Christmas, the world could awaken to the greatest gift imaginable, or the most unsettling revelation we've ever faced. If you followed this journey through countdowns, contingencies, and cosmic possibilities, consider liking and subscribing for more explorations into the mysteries that stand just 40 days from resolution. Share your thoughts in the comments. What do you think December 19th will reveal? And are you ready for the answer? The telescopes are scheduled, the protocols are active, and in 40 days, when 3 Atlas makes its closest approach to Earth, we will either confirm it's a comet with strange natural quirks, or will confirm that something from beyond our solar system chose to come here, chose to approach, chose December 19th. The countdown is running, and after December 19th, the window closes forever. Sweet dreams.